in water, 16 grams of oxygen is proportional to or related to 2 grams of hydrogen. I've rounded those off for clarity's sake. This is in water. Okay? Oxygen to hydrogen ratio is 16 to 2, which would round down to what? Reduce down to 8 to 1. So there's 8 times more mass of oxygen than hydrogen. In hydrogen peroxide, H2O2, the ratio is 32 grams of oxygen to 2 grams of hydrogen, which would round down to 16 to 1. The fact that hydrogen and oxygen can be put together in these two ways, but have a set ratio, is an example of what law?
Law of conservation mass.
Law of what? Well, the fact that it's a 16 to 2 or an 8 to 1 ratio within water is an example of definite composition or definite proportions. The fact that it's 32 to 2 or 16 to 1 in hydrogen peroxide is law of definite composition or definite proportions. But the fact that we have these two kinds of atoms with these different definite proportions is the who, Kelly? Multiple proportions. Multiple proportions or multiple composition. So this question is not nearly as intimidating as it looks when you glance at the page and think, oh my gosh, there's so many lines there. All right, 31. Describe how the mass of an electron was first calculated and describe Millikan's oil droplet experiment and its effect on atomic theory. Well, what did Millikan find with his oil drop experiment? Oil drop experiment, we need to go to Moodle and look at the animations. What did Millikan find?
Millikan. Determine the mass of an electron.
Determine the mass of an electron how? Okay? And what did he use to do that?
Oil.
Now, Millikan did more than this.
He made like a big,
Yes, he made the big container thing.
Yeah.
Remember the animation I showed you with the happy little man rejoicing at the end?
Yeah.
Well, it's posted on Moodle. You can watch it again. Little dancing man. There was rejoicing. And a sweet beat. Okay? Thomson figured out the charge to mass ratio. Charge to mass ratio. Okay? Millikan actually found the charge of an electron first. Okay? First he found the charge of the electron. And he used Thomson's work to find the what? The mass. So that's where we get the mass. So he actually physically just figured out the charge of an electron, 1.6 times 10 to the 19th coulombs.
What?
Yeah, watch Dancing Man. He figured out the actual value for the charge. And he used what Thomson had done with the charge to mass ratio, combined those and figured out the mass. Okay. So eventually, yes, he did find mass, but it was because first he found this. Okay. The next 4 are short answer questions. And one of them, actually number 33, we're going to be working on an assignment tomorrow. We've talked about it in the notes, but we'll do some practice problems tomorrow. First of all, in 32, it says, to determine the number and charge of each subatomic particle in a given isotope, This is going to be so easy. It's going to be just like the quiz. And the example I had in the notes was cobalt 60. Okay, so there's an isotope. How many protons, neutrons, electrons?
27 protons.
27 protons. How do we know that?
It's the
The bottom number is, which is called the what?
atomic number.
The atomic number. So we have 27 protons. Boys in the back. Boys in the back. Watch me. How many electrons?
27.
Why?
It's the same number.
Because this isotope does not have a charge. There's no charge written up here. And how many neutrons? Why?
Because they subtract the atomic mass by the atomic number.
Okay, we're going to subtract mass number minus atomic number to get those 33 neutrons. Okay? So your answer should pretty much look something like this. 33 says, the hint says, use mass numbers of isotopes and their average atomic mass to determine the relative abundance. And we're going to give you one that only has a couple isotopes. And sometimes you can, well, a lot of times you can tell the most abundant isotope by looking at the average atomic mass. So lithium has an average atomic mass of 6.941, which would lead us to believe that which isotope of lithium is probably most abundant? 7, right? Because that number's close to